numbers on a paper.
I am pretty much sure that the comparison test is one of the most difficult methods of testing whether a series converge or diverge, right? But friends, all you need to do is to calm down because it is not so bad as you think. So guys, I shall be explaining to you guys everything you have to know concerning this method of testing. So guys, at the end of this video, you shall be able to understand the concept so well, guys, and score the best mark you can ever think of in your exams. But guys, before I do that, I want you to hit that subscribe button because I can only help you to pass those exams once you subscribe to my channel. Friends, my name is Omenju Makarios, and this is Humble Mark Academy, where I handle complex science problems. I help students to pass their exams so well, and in exchange, I want you all of you to hit that subscribe button, friends. Like the video, it does motivate me a lot. It's very important, guys. Share the video out and comment. It motivates me, all of that. So guys, let's get started. Great, friends. All right, so guys, for the comparison test, we need to have two series. We can call that the series as n goes from k to infinity of an, and we also need the series as n goes from k to infinity of another series where we have bn. So guys, what makes the comparison test generally very difficult and not students friendly is for the fact that we need two series to compare. Okay, we need two series, unlike for the other methods of testing, wherefore we need just the series we have to test. Great. So guys, like I said, I'll explain everything for you guys, and if there's something you still find it and if there's something you still don't understand, guys, feel free to leave it in the comment section down below. I'm going to get back to you as soon as possible. All right, so now guys, the comparison test simply has two parts. We have the direct comparison test and we have the limit version of the comparison test. We shall see all of that in this video today. So guys, let's look at the first one. Let's look at the direct comparison test. Great. So guys, for the direct comparison test, right, if we have a series such as an, such as the series as n goes from 1 to infinity, as n goes from k, right, to infinity of an. Friends, keep in mind that we are dealing in this case for now with positive series, okay? Series of positive numbers. So guys, in this case, our n starts from k. The reason I put k, like I said initially, was that the starting value of this our series does not really matter. Okay, it doesn't really matter. Great. So guys, when we have a series such as series from n equal to k to infinity of an, we want to test if this series converge or diverge. If we know another series, right? Perfect, guys. If we know another series such as bn, and guys, if an is less than or equal to bn, guys, even if in the exam you put just less than, you are still correct. Okay, you're still correct. The equality sign does not really matter, but I'll just put it. Okay, it doesn't hurt. Its presence or absence does not really hurt. Great. If an is less than or equal to bn, and guys, most importantly, and if bn converges, then guys, we can conclude solemnly that an as well must also converge. Great. That therefore implies the series as n goes from 1 to infinity of an, guys, also converges. Guys, let me take it again. If you have a series such as from n goes to infinity to from n goes from k to infinity, guys, of an, your aim is to test if this series converge or diverge. If you know another series that converges and the series you are to test if it converge or diverge is less than a series you know that converges, then you can conclude solemnly that your series as n goes from k to infinity of an, guys, also converges. Great. And guys, similarly, in the same way, if we have a series as n goes from k to infinity of an, if we know another series such as a series as n goes from k to infinity of bn, if bn diverges, right? Or better still, guys, if an, the series of an, guys, if this series is greater than a series that you know, such as a series containing bn, then guys, if bn is divergent or if bn diverges, then guys, we can conclude solemnly that the series as n goes from 1 to as n goes from k to infinity of an also diverges. All right, guys, I'll explain again. Okay, I'll explain again so that you are going to get it so well. If we have a series such as an, right, our goal is to test if an converges or an diverges, right? Great. And we know of another series that is less than an. If that other series that we know diverges and our an is greater than the series we know that it diverges, that therefore implies an also diverges. In other words, guys, when we have a series that is less than, if we have a divergent series, okay, that is less than a series that we don't know, that therefore implies that series we don't know, guys, actually diverges. Great. So guys, you can see that this version is completely opposite, right, as regards to this other one. Wait, all right. So guys, I think we should look at an example that way you're going to understand. So let's test whether the series below converge. All right. So guys, the series is simply the series as n goes from 1 to infinity of 1 over 5 raised to the power n plus n. Great. All right. So guys, this is the series we have, guys. So please pause the video and give it a try. Then I'm pausing now to check the solution. Done? Great. All right. So guys, this is the series we have, right? We can say that when n goes to infinity, right, it therefore means that what, guys? This n, right, is a very much small function compared to what 5 raised to the power n, right? So this our series, right, is less than or equal to the series as n goes from 1 to infinity of just 1 raised to the power 5, okay? Because the n in this case does not really matter when this series gets so big, okay? N has no c compared to 5 raised to the power n. So this guy is smaller than this. In other words, guys, the bottom of this our sequence, right, is heavier than the top, right? So in this case, we have simply reduced the bottom. That therefore means that this series now is bigger than this. Namely, this series is now less than this. But friends, we can see this guy as the series as n goes from 1 to infinity of, we've written this guy now as 1 over 5 all that raised to the power n. And friends, we can see that this our series now is what is a geometric series, right? Great. But guys, you don't have to end there. You have to tell them that it's a geometric series whose r, that's a common ratio, is what, guys? 1/5. But guys, saying that common ratio is equal to 1/5 does not really help you. But you should rather tell your professor that you know that the absolute value of r is what, less than 1. It therefore implies what, guys? When it's less than 1, it therefore implies this our series therefore converges, right? Because when the absolute value of r is less than 1, it therefore means that the series converges. Great. In the same way, guys, when this series converge, it therefore means that this our series, right, in fact, we can clearly see that this our original series is less than this series, right? And this series does what? Converges. Is the same thing we did here, right? That if an is less than bn, and if bn converges, therefore means that what, an also has to converge. This our series is less than a known series that we know that converges. It therefore means that what, this original series, that is the series as n goes from 1 to infinity of 1 over 5 raised to the power n plus n, also converges. Guys, the word also in this case is very important, okay? We have to state in the test by the direct comparison test. Great. So guys, if there's something you understand, like I said, guys, please make sure you let me know in the comment section below. I look forward to answering all your questions. All right. So guys, this is a version of the comparison test, namely, guys, the direct comparison test. Let's now go ahead now to look at the limit version of the comparison test. Great. Then guys, we shall draw some analysis. All right. So guys, that's the limit version. Again, guys, in a similar manner, we need a series such as from n equal to k to infinitive of an. Our goal is to test if this series converge or diverge, right? Now, the limit comparison test is simply saying that if we have another series, such as a series as n goes from k to infinitive of b, and guys, if the limit as n goes to infinitive of bn over an, if it gives us some constant which can call that c, in this case guys, where c is a finite non-zero constant, if this limit gives us a constant that's a non-zero constant, then guys, we can conclude that if an guys converges, then bn also has to converge, or the series of bn guys also has to converge. All right, guys, I'll take it again. If we have a series from n equal to k, right, to infinitive of an, right, then we have a series from n equal to k to infinitive of bn. Our goal is to test if bn converges. But if we know another series such as from n equal to k to infinitive of an, if an is a convergent series and the limit of bn over an gives us a constant c, and we know that what an converges, it therefore means that what bn, the series of bn also has to converge. Great. That's it, guys. And in the same manner, guys, if an diverges, then the series of bn guys also has to diverge. All right. So guys, this is how the limit comparison test is simply saying. This is how it is saying, guys. Let's look at an example that I'm going to explain qualitatively for you to understand. Great. All right. So guys, let's test whether the series below converge. We have the series as n equal from n equal to 1 to infinitive of n plus 1 over 4 raised to the power over 4 n over the square root of 4n raised to the power 3 plus 1. All right. So friends, we need to observe that we are to use the limit comparison test to verify this. Okay, that is what we are to use. Great. Now guys, we have to observe that we know for sure that the series as n goes from 1 to infinity of 1 raised to the power square root of n, right? This is simply the same as the series as n goes from 1 to infinity of square root of n is the same like what? N raised to the power 1/2, right? Great. In this case, guys, this is a famous P series that everybody likes, right? Great. This is a P series where in this case our P is simply what? 1/2, right? P in this case is 1/2. And guys, most importantly, 1/2 is what? Less than 1. It therefore implies that this our series does what? Diverges, right? Great. Keep in mind that when P is less than 1, the series diverge. When P is equal to 1, it is what? The case of the famous harmonic series, right? Which also diverge. When P is greater than 1, guys, the series converges. Great. So now, guys, now that we know if this series, we know that this our series that we know, keep in mind that we are to test if this series converge, right? But we know that this series, this other series, the series as n goes from 1 to infinity of 1 over square root of n diverges, right? So now all we have to do is to take now the limit as n goes to infinity of what's our bn, guys? We have 1 over square root of n, right? We divide it by an. Dividing by an is the same like multiplying by the reciprocal. Keep in mind that here we have n plus 1 over the square root of this. In this case, we are multiplying by the reciprocal, so it's the same like dividing. So guys, when we simplify this correctly, guys, so well, we know that when n becomes so large, right, this 1 in the denominator has no c compared to this n, right? Likewise, this has no c. So we are going to be looking at now the square root of 4n cubed. Square root of 4 is simply 2, right? So we have n raised to, that's n cubed inside the square root. That's n cubed raised to the power 1 half, which is simply n raised to the power 3 over 2. Then we have square root of n, namely n raised to the power 1 half plus n times n, which is simply n raised to the power 3 over 2. It will cancel with 1 we have at the top. At the end result, we are going to have an answer of 2. Guys, what is 2? 2 is a constant, right? 2 is finite. And guys, was this series convergent or divergent? It was what? Divergent, right? It was a P series that where our P is 1 half, which is less than 1. It therefore means that what the series diverges, right? So now, if this series diverges and the limit of a divergent series with another divided by another series has given us a finite value, and this series diverge, it therefore means that what the series as n goes from 1 to infinity of n plus 1 over square root of 4n cubed plus 1 also has to diverge. And this is so by what? The limit comparison test. Great. So guys, that's it. So friends, an important note. In this case, we had the limit as n goes to infinity of bn over an, right? It could be an over bn, okay? It is still the same terminology, okay? It can still be an over bn, it's still the same. Wait. So guys, that is what the comparison test is saying, guys. Namely the limit comparison test and the direct comparison test. Suppose that this series we used was a convergence series, right? And we had a constant. Therefore means this guy would have been a convergent. Great. So guys, as always, guys, if there's something you don't understand, please feel free to leave it in the comment section down below, guys. I promise to get back to you as soon as possible. Thank you very much, guys. Like I said, don't forget to subscribe to the channel. That is going to motivate me to keep producing more great content for you guys. Thank you very much. Have a blessed day.